Hello, everyone. Welcome to this session. I hope you had a great keynote and you heard our keynote from the Adrian, and it was really a great session. So now, jumping to our first session of the track two, that's from Renaldi, and we're gonna talk. He's gonna talk about building a system resilience with chaos engineering for serverless application on AWS. So, welcome, Renaldi. Renaldi is a founder and a project leader for Gress Studio, and he's also a developer advocate for tech communities. And through his passion for developing software and contributing to open source community, and he wants to encourage the innovation of a new solution to usher forward and promote a new era of innovation that can used by everyone. And he has been a tech speaker in numerous events for the past 4 years and runs a tech meetups and workshops to promote a better understanding of technical skills. So here we go with the Renaldi. So over to you.
Thank you, Peshek, for my introduction. So I'm just gonna get straight into it, and I'm just gonna share my screen to start it off. So, welcome all. I'm Renaldi, as I introduced before, and I'm going to be giving a talk building on system resilience with chaos engineering for service applications on AWS. I hope everyone's having a great time at the conference so far, especially since I know that there are many very interesting and very insightful talks that are going on so far at the conference over these 2 days that the conference is going on. And I'd like to also give a big thank you before starting out to the Chaos Carver Committee as well for having me to deliver this session. And a big thank you as well to all of you for being here to listen to my talk and to learn some new stuff about how you can really use chaos engineering for AWS. So, without further ado, let's get straight into it. So, the agenda will be composed of 5 different elements. So, firstly, we'll be talking a bit about chaos in the cloud, getting a bit of motivation on really understanding more about why we want to do chaos engineering on the cloud in general and how we are able to choose to do it. Second, we'll talk about endeavors in the cloud. Essentially, I'll be going to a 5-step process of endeavors that you'll go through for applying chaos engineering on the cloud. And it's a good framework to abide by whenever you essentially will go through creating new chaos on the cloud, preparing new chaos procedures, and many more. Third, I'm going to be giving a sample architecture on applying this kind of chaos and really showing how it can fit within the AWS architecture and where can we apply the chaos. Fourth, of course, applying chaos itself, which is, I'm sure that many people are here for that because we want to be able to understand the practicality of how we're able to apply chaos on the cloud and really understand where we can really do that. And finally, what we got out of it. I'm going to talk a bit about what I got out of it personally, the value I got out of it, and what you can also get out of it as well on the side. So let's dive into it. So a bit more myself before we start. As mentioned before, I'm a founder, a project leader, and developer advocate at Gress Studio. I'm 12 times AWS certified, 3 times Azure certified, and 2 times Google's Cloud certified. My personal field of interest is within penetration testing and accessibility practices, but on the side, I also run meetups. I personally run a few tech meetups as well, currently situated in Melbourne. I've also run a couple of hackathons on the side as well. I've, of course, am doing tech talks as well. I love sharing with the community what I found, my passions. And of course, I'm also a VR tech enthusiast. So if you want to talk to me about other stuff such as that, feel free to talk to me as well about that. I'm more than happy to really share about my knowledge regarding that. So first off, chaos in the cloud. The way we work is changing due to COVID-19, especially the bigger transitions towards serverless applications. Because I'm sure that most people here has already experienced some changes due to COVID-19 into the way they work. More and more stuff are going online. And that's much more reason on why we need to be able to really understand that. There's been already a lot of surveys that have found that there are currently massive transitions towards the cloud due to this whole COVID-19 situation. We've been seeing much more shifts towards this kind of culture, and we've been going from more of this work from home culture. And this way, we need to be able to make our testing more resilient than ever. We need to be able to be more prepared for faults, possible misconfigurations, and such as that. And essentially, that's why we need to be able to be ready for any particular thing that can happen, essentially. And of course, when we talk about the cloud, we need to first cover the main principle of, and there are three of these principles that currently are already very prevalent that are also very relevant towards us testing it within chaos engineering. And these three principles are resiliency, availability, and adaptability. Of course, resiliency in chaos engineering is a pretty no-brainer. It essentially deals with how we are able to recover quickly, such as when there is a particular fault, and how resilient is it towards failure or other disruptions. And that's essentially what chaos engineering wants to cover within the cloud. We want to be able to test how robust is our system currently and how resilient is it towards potential threats. And of course, availability. How available is our currently system? Is our system currently already prepared to fail over or such? And of course, adaptability. Can we adapt towards changes? Because workloads will change on the cloud, because not only do workloads on the production environment change, but within the client side, it can also change as well, because client demand will eventually also ramp up over the cloud. And because not so many stuff happen on premises due to COVID-19 anymore, based on workloads on the cloud. There will definitely be much more clients requesting for services within the cloud itself. And that's why we need to be able to adapt quickly towards increasing demand and really be able to be flexible towards whatever changes that may occur in the cloud. So I'll be going now over the 5 endeavors. So the first endeavor, essentially, this will be about defining stability. And when we plan for chaos engineering to occur, we first need to be able to define what we consider stable on the cloud itself. So, firstly, we need to consider what is considered as normal behavior. This is an important consideration because we need to be able to find a steady state, essentially, this state of the cloud itself. And what do we consider normal behavior? How do we want to choose to measure success, and what metrics would we like to use to be able to do this? How does our normal behavior align with our particular business objectives? And essentially, this is very important for us to be able to scope out first, because we want to be able to understand how we can do this and how we are able to adapt this towards our particular objectives. And essentially, by doing this, we're able to understand if our current objectives are already correct or not, and of course, if they're already aligned with the business objectives or not, the behavior itself. Second endeavor, and this is called the estimation process. It's essentially the use experience. You're able to use your experience to consider how you're able to solve the problem and to be able to consider where chaos can be injected based on that. Of course, nothing beats experience after all. First times trying out chaos engineering may be a bit tricky on the cloud, as I have experienced before as well. It takes a bit of time to be able to configure the policies, for example, and really understand the particular timeouts, and spend a bit of time reading on the documents that are provided based on AWS. But of course, with experience comes the real potential of being able to make the change and be able to consider better. And essentially, that way, we're able to better understand how we're able to apply the chaos on the cloud. And also, of course, considering the particular places on where chaos can be injected. We can of course definitely get recommendations on where we can inject that kind of chaos based on our searches, for example, or based on our previous colleague experience. But of course, nothing can beat dark experience, and from that, learning really which places are the most effective to be able to inject chaos. The third endeavor, execution. Essentially, this is a particular section focused on execution itself, and we are able to create a flow diagram of how we want to be able to plan to execute our particular chaos engineering. And with this, we want to be able to also prepare containment methods as well, should our tests fail. And of course, we expect it to fail because in chaos engineering, we do want failure after all. We do want to see how robust our system. Of course, because we want to be able to understand that so we can fix it. And of course, setting up notification methods if our test does fail, such as setting up it on Slack. AWS has an integration on Slack, for example, that we have already been able to utilize. They basically getting messages directly from the pipeline, and also being able to be notified directly from, such as from AWS's messaging service as well, so that we can get it on our phones. So all of this really contributes to how we are able to plan our execution and really be able to further understand how we're able to contain such particular problems and really understand better on how we want to be able to execute this particular phase. The fourth endeavor, evaluate. So in evaluate, we want to be able to define metrics that measure success. We want to be able to measure resiliency, that is experience within systems, and we want to be able to understand the the process of continuous evaluation. We want to be able to really evaluate to be able to better facilitate further fixes towards this resilience for systems, and really figure out how we're able to measure resiliency, how robust our system is essentially, define the metrics that we want to be able to measure to be able to find that out. So with evaluation, we can continue to have iterative development and further improve our system. And of course, fifth endeavor, reiteration. Improve based on your evaluation and understand the effects based on the improvement. Really understand how we're able to further improve and be able to understand how we're able to best build on the system to improve the effects that are created based on our previous findings, and continue on with that process until we reach a steady state that we agree with, state for our particular system. And what do we need to watch out for throughout our particular chaos engineering on the cloud? Handling various responses, and I'm going to talk about this quite in depth in a bit. So in AWS, we have a lot of different things to worry about. Many of this is including in such as like responses include like timeout that of each particular service, because each particular service has its own timeout. So we need to be able to adapt other services testing based on that, and of course our system overall based on that, and of course how we choose to be able to create chaos to an acceptable level. We don't want to create chaos to a point that we actually break the whole system. We want to be able to create it to an acceptable level, and we need to be able to define that level beforehand. I'm going to also cover this as well, how we're able to define an acceptable level for chaos. And of course, creating failover plans should be a no-brainer for every AWS developer out there. Always prepare for availability. That is one of AWS's pillars after all. Be able to prepare for availability and, of course, prepare for failover whenever necessary. Because despite however robust you think AWS is maybe, it always has the chance of going down. So always prepare failover plans for other regions, for example, or availability zones and other such like that. And this is a simple architecture to start out by. So let's just say that we have a particular architecture that connects us this way. So we want to be able to use DynamoDB as our particular database, and of course have Lambdas in between, and we have an API gateway that it acts as the border between our code and a Lambda. And so we pass from our computer itself to API gateway, going into Amazon Lambda and DynamoDB. And of course, we may have S3 as another code source. So it is just one example of how it may look like. And essentially, in this particular case scenario, I'm going to talk about how we can apply chaos in this case scenario. So essentially, in this particular case scenario, the question is, where do we want to choose to apply our chaos? Which component do we want to be able to choose to apply that? And essentially, this may look simple in first glance, but there are actually many considerations that we need to consider when we first talk about where we want to choose to apply the chaos. Because we need to be able to consider such things such as what the timeouts of particular services and the functions of particular services, and of course, how will it affect our system as an overall, which is one of the most important stuff as well. And does that meet our overall chaos engineering goals based on our business objectives as well? And I'll be going over this in depth in the next few slides. So creating our own playground to experiment is very important, of course, because we want to be able to create a production environment first, but also one thing I often find interesting is also to be able to create another test account as well. Sometimes, of course, after all, since we're applying chaos, things may get a bit out of hand. So it's important to be able to make production environments that really are geared towards testing. So being able to play around a bit and understand how you can be able to play around a bit is very important. And of course, experiment with varying parameters is another important thing as well that you can do at test accounts. And this is where I get in depth as well with the previous architecture I mentioned. Latency spikes is one big issue that I want to talk about in particular in this particular slide, because latency or performance issues are essentially the most common issue in production. These issues may include stuff such as network issues, overloaded servers, and more. And API gateways also have interestingly, they have a hard time limit of 29 seconds for timeout. So essentially, it needs to be able to be configured accordingly, even if other services that use it can run for, let's say, 5 minutes or more. Because if this times out earlier than the other services, then essentially it's already a botched cause essentially for our other service as well, because this will essentially time out before the other services. So this is one particular case example of being able to build around other services when we want to test our chaos. So within this, the question is, how are we able to build around this? And the answer is on the next few slides. So essentially, let's say that in a particular case scenario that we mentioned before, for example, when we talk about, say, want to be able to create a particular HTTP client, we can inject it, for example, within the HTTP client library. But for DynamoDB, for example, as we mentioned before, we are able to actually think about in the case that we want to be able to inject within some place that can ensure that the overall function degrades gracefully. Example of it, essentially, is being able to inject it within the AWS SDK itself, the AWS SDK library, to be able to, when it's in the process of sending data to DynamoDB. Essentially, this will help us to be able to ensure it degrades gracefully, because we want to be able to ensure that we are injecting it in a position where the request would still be able to be obtained. And that way, we can also test for, particularly for the function's timeout as well. Same thing if we do inject it with, for example, within a client library. We need to be able to test that can degrade accordingly within the request timeout. And because we need to be able to factor this in before considering as well on how we want to be able to make this work with other services. And of course, this is just but one simple architecture, but many different architectures may contain much more complex components compared to this one. And all of this has to be adapted towards your particular case scenario. And this will also depend on your particular set policies. Policies is another thing as well. We need to be able to consider what kind of policies do we need to be put through, and essentially how we choose to be able to adapt them towards our particular case scenario. And of course, as I mentioned before, We have our two samples that I've talked about, putting in a Lambda, putting a DynamoDB, and essentially it can be done anywhere on AWS, not only on those two. So you're welcome to try it on any other service essentially that are you already currently have in place. And I'm sure that AWS has already a lot of documentations regarding timeouts of each particular service and notes regarding each particular service. So those all need to be taken into account when considering where we choose to inject it. And of course, we also need to inject it in a place where we can ensure that our overall testing can degrade gracefully, because that's the particular behavior that we want from our particular service to actually have. Because chaos essentially is going to be chaotic, ironically, if we don't control it perfectly based on our particular testing. And here's just an example of creating a particular test client for apply chaos in DynamoDB. So just an example of a function that it has. So this particular example, we're essentially creating a test client to be able to test this. So we use region as a particular argument. We return the DB client builder and return standard. And essentially, we are able to then use some functions that are just like just typical functions like getting the region first, getting the client configuration. And the important thing of this too that I want to point out really, and the purpose of having this is really being able to specify correctly the client execution timeout and the connection timeout. Essentially, these particular values are declared in milliseconds. Essentially, 2,000 milliseconds per client execution timeout, for example, and 300 milliseconds for connection timeout. And these essentially have to be able to be specified accordingly based on your particular services. So in this particular case scenario, this is considering the particular architecture, but on your particular architecture, it may be also different. So it's also important to play around a bit as well with particular settings on the particular timeouts as well to be able to make one that really fits with your particular case scenario. And of course, attach and retire policy is very important as well to be able to put through when you want to retry and how you choose to retry the particular function. So this has to be able to be put into consideration. And you may need to be able to specify this in order to better put through the retry policy. You could put your own policy, or you could use DynamoDB's retry policy by default as, for example, in this particular case scenario. So after that, just execute the build. So essentially, we need to be able to consider components first, and we need to be able to consider what their behavior is before specifying the timeouts. And after that, we can specify the timeouts as evidence over here. And of course, when we configure policies, this is one particular case scenario of what I did in Lambda, for example, for one of my case scenarios. So in this particular case example, we're just specifying some stuff such as enabling that particular policy, basically enabling failure mode as latency, putting a rate, putting a minimum and maximum latency, especially over there. And of course, giving exception message, status code, space, and do not. So this is a particular normal policy for a particular Lambda instance. But these are actually more important than many people give them credit for. Most people always give people credit for a policy just as kind of like just as a security measurement, essentially. But they actually do help a lot as well within being able to test for chaos engineering. We need to be able to set these accordingly as well to be able to really stretch the bandwidth of like how our functions can handle workload and how we can choose to be able to further build upon that and of course adapt based on that. So we need to be able to test with different measures. We can test with also very extremely low minimum latency and very extremely high maximum latency, or vice versa, and test how this code scales essentially with our current workload. And that way, we're able to really understand the extent of our particular system. How we can really build upon that really matters based on this and how we're able to better understand our particular service. Next is being able to create a post-incident strategy. Essentially, in this particular case scenario, we need to be able to address what happened. How did this particular error affect your service? And post-incident strategies are not only for already failed and kind of trials, but they're also essentially in when it's released already. But it also needs to be a thing, even within testing itself. If we do experience some kind of an error or unexpected behavior, how do you want to address it in each scenario? These all need to be prepared, and chaos engineering is no better friend to be able to help you prepare for this, because it gives us an image of how bad it can essentially be stretched to, and how can you control the chaos better next time. What metrics you need to evaluate and reevaluate, essentially, to be able to consider how we want to be able to address the issue better. And what are you already doing now to be able to fix it? That's essentially the whole point of case scenario, after all. We want to be able to make strategies to be able to address these issues and try to, of course, combat them beforehand and prevent these issues from actually happening. But if they do happen, we need to still be able to have fallback strategies and essentially create the strategies needed to be able to address it should a real error occur. And that's why we have these test occurrences within chaos engineering, because we want to be able to measure it beforehand as well. And for this, we want to be able to create a weekly inspection schedule, for example, for the chaos engineering flow. We want to be able to focus on maintaining that every system item is working well and within the system. And essentially, one recommendation I always have for different teams that I believe is already adapted much as well into a lot of companies these days, due to, of course, not even before COVID-19 hit, it's become more and more popular, especially with the current work from home culture, the agile scrum culture, of course. So essentially, being able to hold weekly meetings, daily meetings, essentially, and really giving it some time to talk about security incidents, and sometimes also talk about chaos engineering is very important as well for teams, I believe. And of course, this really helps with being able to make sure that every item is addressed. Every item in every component of your current system needs to be addressed in terms of chaos engineering. This way, we can test for conduct a full scale, essentially scan of like the whole system. Essentially, create the procedures needed to be able to create for chaos engineering. And with this particular system in place, we're able to better facilitate for items that may appear on the flow, and essentially create better discussions along the way as well, as to like how we can approach this in the future, how we can choose to address these issues in the future, and what we really need to be able to build on towards in the future. Address any single incident that may happen, which in the case of work from home, a lot of them still do. So we need to be able to always be prepared for that. And I'm just going to mention a quick case study based on what I've done previously as well. So what I did previously as well was essentially I needed to be able to build a resilient system for an IoT network. So essentially this is involving a lot of devices involving microcontrollers, and essentially we want to be able to consider a particular client constraint of low bandwidth areas. Because as previously, this is an example of being able to adapt towards different situations. And of course, AWS also has this in a few recommendations as well, talking about how you can use services to be able to address low bandwidths. For example, if you go to the AWS IoT particular service within AWS, they do have a bit of applications regarding that, including AWS Greengrass as well, to be able to talk about how you're able to better address the bandwidth in low areas, and how you can facilitate for, like, for example, say if it actually goes offline. So these examples are one of the extreme examples, I'd say, of being able to consider chaos engineering, because there is the possibility that it may go offline. And essentially, this is essentially one of the most interesting instances of where it would essentially go wrong. And we need to be able to also best utilize the cloud platform to facilitate it. We need to be able to consider how we want to be able to utilize the cloud platform to facilitate it. And essentially, this is all part of the for the system for the IoT framework. So, what's the solution? What we did, we put selection of testing on Lambda, essentially. We put testing on Lambda, as I mentioned before, put it on the HTTP of public-facing libraries, essentially. We tested, we did testing based on put high pressure on bandwidth and locations. Essentially, we tested particularly in cases of such as like offline, if such our service did go offline, because we can't control, of course, if our servers all stayed online. Some in developed areas, we can always consider that, but in less developed areas, we may not be able to control that. And that's the thing that we always need to be able to control. And in chaos engineering, that's what chaos engineering is for. We want to be able to control the chaos as much as possible and prevent the chaos from starting as much as possible. And that's why we want to be able to choose this as nicely as possible. And this picture on the right side is just an example of some policies that are set to be able to address this. For example, address some parameters such as putting in a delay, putting in error code, exception, and exception message, and putting in the rate. So this all can be set essentially for within systems testing, and we want to be able to put this within the parameter testing when we put it through. And essentially, we would like to be able to also schedule testing accordingly as well. Put regular testing schedules, put it on a daily basis, weekly basis, depending on your current needs. Of course, you may want to be able to put it more frequently, put the testing done more frequently when you do start to actually approach the D-Day of the particular deployment, for example. But within the production environment itself, where it's still far away, you could put it like still spaced within more less regulated intervals. And there definitely is more of a need for agile in chaos engineering. Agile is all about iterative development. We want to be able to consider particular chaos engineering that actually does need fast reactions. We want to be able to consider how we are able to prioritize disaster recovery when we do choose to actually do chaos engineering. So essentially, there is a greater need for agile because we can react faster to incidents based on agile. Because agile is really all about being able to update according to what is happening recently. Really be able to come up to date about what is happening on the spot. So that's what you want in these particular instances. Because chaos engineering also requires you to react fast, depending on whether it's a production environment or if it's already live. Essentially, we want to be able to react fast to that because even if it's a production environment, it's still part of our testing. And how fast we react to that is just a testament to how fast we can react as well when we actually encounter such an issue live. So that way, we're able to address issues faster as well. So this is why I believe that there is also a greater need for agile as well in chaos engineering as well in general. And what did we get out of it? We got agility, as I mentioned before, of course, with agile. We want to be able to react to stuff faster. We got satisfaction out of the current particular system. And we got essentially a culture as well. We build a culture based on chaos engineering because essentially I believe that chaos engineering is not only a practice, it's also a culture. It's not so different compared to let's say DevOps or DevSecOps or a waterfall. I would consider particularly chaos engineering to be a culture as well, especially within the cloud, because we're able to apply it. We need to be able to apply it, and we need to be able to consider other people to be able to apply it as well. And we need to also really also give our colleagues as well the experience of really being able to chaos engineer your way out of things, because I believe that it is something that needs to be familiarized with within the whole company. It's something similar to DevSecOps. DevSecOps, you can't really get something throughout the whole. You can't apply the process without the whole company understanding it. Because if someone does DevSecOps and another person actually does skip over it, that's supposed to also be paying attention to it, it doesn't really work out. Same with chaos engineering. We want to be able to have everyone acquainted to understanding how it works on cloud and understanding how we can be able to address things on the cloud that way. That way, we're able to better understand how we want to be able to consider doing it that way. And that's all for me. Thank you. And I'm going to be now addressing some questions currently that I can find on the Q&A section.
Yeah, thank you, Randy. That was really great session. I mean, I enjoyed it thoroughly. I mean, I haven't done it like in practical, but your case studies and the methods you explained were pretty good. So I have like two questions for you, and we have two more questions in the audience. So the first question is: so since you mentioned AWS as a platform, so I mean, so our production apps which are already using AWS platform, do they really need chaos engineering, or is there a way that AWS already takes care of it by default?
Thanks, Abhishek. I do believe that AWS has a lot of measures in place. A lot of case engineering is already taken care of, really, because we have availability failovers, and that's the great thing with AWS, really, because we already have we're already able to set up failover instances. We're already able to make use of features that AWS provides to be able to provide us with different measure essentially to be taken into place. They provide the metrics, they provide the rates, and they provide us also particularly the possibility to be able to by default set over failover policies, and they already provide essentially policy by default to be able to for us to fail over to as well. But I would say that further stringent testing on chaos engineering would never hurt, because I believe that some stuff can really be
Is there a problem? I guess it's all right. Your screen is like disappeared, I believe. Do you hear me, Renaldi? Okay.
Sorry, did I go off just now?
Yeah, it's all right. I mean, you did go off, so that's all right. So yeah, so coming to your second question, do you hear me?
Yep, I do hear you.
Yeah. So since you actually mentioned to start with the test environment, so the other question comes in like, where do you exactly start your chaos engineering thing? Like, do you directly start with a DB, or it should be a CI/CD pipeline, or it should start with your microservice architecture itself?
I would say again to firstly consider what elements you're currently putting in, because oftentimes it does take a bit of experimenting as well on what particular component you choose to actually induce the chaos engineering on. As I mentioned before, for example, when we talk about DynamoDB example, we choose it, for example, in the AWS SDK library, of applying it in that library. And that's because that library in particular allows us to be able to have the ability to be able to degrade gracefully based on that. So same for other particular components as well. I'd say that it definitely depends on the particular components you have, and it takes a bit of experimenting, considering setting different timeouts, and really considering different policies that you set based on that.
Yeah. So now I'll take a question from audience. So the first question is from Billy. He's asking, how quickly can you disable chaos in the Lambda function if you find a failure?
I would say that you could definitely do it very quickly. it also depends on your particular chaos engineering policies that you set in place as well. Because I believe that AWS does allow you to be able to, for example, stop service, for example, or be able to provide contingent measures almost instantaneously based on your current performance. But should there be more pressing issues that do require manual interaction, it'll definitely depend on you as an engineer to be able to disable it. So in the end, when that does happen, it comes down to you as an engineer on your response time. So that's why post-incident preparations are very crucial towards this.
I hope that really Renaldi answered the question. So another one is from Arco. He's asking, should we apply chaos engineering directly on production clusters? Is that wise? Because he has heard that Netflix does it.
So this is an interesting question. Personally, I have not done this. I've not done this that much because I always stress on doing it on testing environments. But if you do believe that your system, if you do believe that your production cluster won't be that affected by the chaos, and it won't really cause much production problems down the line for your really well, of course, when it's out of the production environment, I'd say it's definitely okay. But it's just something that I've not done a lot personally because I do prefer putting it on a personalized testing environment because we do expect things to go wrong and things will go wrong. So that's just one thing that I always put in consideration.
Yeah. So another question from the same person. So how frequently do you suggest a team meet to discuss the fault injection strategies? And what are the key areas the team should look into first?
Good question. So, as I mentioned before as well, it definitely depends on the case scenario. So, it definitely depends on your particular needs. How fast do you need the product to be out, for example? And essentially, we may firstly start out with when we want to like release a new thing, we may conduct more stringent. We have a more stringent process. We may review it daily, for example. We may continually have it like that. Or if we are still in like a development environment, planning environment, we may have like weekly meetings addressing the most crucial issues. So I'd say it definitely depends on the most important aspects first. And regarding few key areas that the team should look into first, definitely depends on where we expect most chaos to occur, especially in regards to the more chaotic parts, like just like DynamoDB or Lambda. They may have more chance of an error occurring. Let's compared to let's say some of AWS's other already stable services, example. So it definitely depends on the service you're using based on that, and essentially that's what you need to take into consideration when you discuss as well and decide the particular lengths of time before you in between you conduct each particular team meeting to be able to discuss the fault injection strategies.
So basically, completely depends on your use case. Plus, always the first way to go it with the vulnerable part, right?
Yep, that's correct.
Yeah. So I guess we are up with the time and we are on time. So thank you so much, Randy, for your time. I hope people enjoyed your talk. I did it personally. So thank you, everyone. Tune in for the other sessions. And I hope Randy will enjoy our other session and entire conference as well.